What's good, YouTube? It's Almond with the sauce, and I'm back with another Algebra 1 video. In this video, I'm gonna be going over solving systems of linear equations. I'm gonna show y'all the 3 types of answers y'all can get, the 3 ways to solve them, and just working some examples. So get your pencil, get your paper, and let's get into it. All right, so suppose you're a basketball coach and you're trying to look at your efficiency of your players, thinking about how many 2s they make versus how many 3s they make in a game. So in one particular basketball game, let's say they score 80 points in the game, you know, points coming from 2s and 3s, and they scored 37 baskets total, a combination of 2s and 3s. So let's say we want X to be our number of 2-point baskets, and then our Y to represent the number of 3-point baskets. So one equation we could do is the number of baskets we made, which was 37, and that came from 2s and 3s. We're not really considering free throws right now, but let's say we made 37 baskets total, and we scored 80 points, and those points came from 2 points for every 2, obviously, and then 3 points for every 3, totaling 80 points. So stick around for the end of the video. I'm gonna show you how to figure out how many 2s they made and how many 3s they made using a system of linear equations. So what does systems of linear equations even mean? Basically, it's like a collection of 2 or more equations. It could be more than 2. Usually it's 2. You sometimes might get 3 equations, but it's usually 2 equations that work together in such a way to where both X and Y are both satisfied in both equations. And when I say satisfied, I just mean whatever number you get for X and whatever number you get for Y, those numbers are gonna make both equations be true. So that means the solution or the answer to a system of equations is a combination of X and Y. So usually, you know how most math questions, your answer is like X equals 4 or Y equals whatever. Systems of equations, you have 2 answers really. You have an X and a Y. So just keep that in mind. Thinking about it graphically, they're linear equations, so they're literally just 2 lines, and the answer or the solution is the point X, Y at which both of those points cross. So you're basically solving for the intersection point. So what's important to notice with systems of equations is that since you're dealing with two variables, X and Y, you need 2 equations to be able to solve for both variables. So what I mean by that is, let's take this equation for example. Let's say I give you 8x minus 2y equals 14. Pause the video and try to solve for y, giving me an actual value or like a number for y. You'll notice that you can't do it because there's an X in there. So no matter what you do, you can get Y by itself, but there's gonna be an X in there, meaning you can't solve for an actual number. So what we do is we introduce a whole second equation, and you'll see soon that because there's 2 equations, we can solve for 2 variables. All right, so let's talk about how to solve these things. There's 3 main ways to do it. All right, so there's graphing, there's elimination, and then lastly, there's substitution. These are the 3 main ways in which you can solve systems of equations. The first one, graphing, I don't really want to get into that too much because literally all you're doing is just taking 2 equations, graphing them, and seeing where they intersect, if they even intersect at all. And I'll talk about that too. All right, so the second way to solve systems of equations is through a method called elimination. And elimination is really good to use when you got the X's or the Y's that can cancel out because they have matching coefficient. All right, so in this example, you see we got 3x minus 2y equals 17 and 6x plus 2y equals 10. Now, obviously you want to stack up your X's, stack up your Y's, and then stack up your constants. Now, if you notice, look at the Y's. You got a negative 2y and a positive 2y. So what you do is, it looks weird and it sounds weird, but you can actually add these 2 equations together. And when you do, you notice that the negative 2y plus 2y is 0y. So that's why it's called elimination, because the y's basically cancel out. So if I'm adding these 2 up, 3x plus 6x, that'll give me 9x. And then negative 2y plus 2y, like I said, is going to cancel out. It's just 0y. And then 17 plus 10 is going to give you 27. Now, because you have the y's canceled out, you now only have one variable in one equation, so we can solve for x. So just like a regular algebra problem, one step, divide by 9 on both sides, x is going to equal to 3. Now, a lot of people are going to want to be done, but remember, a system of equations is when you're trying to find a x and a y. So when you find the x, you're halfway there. And the way you solve for the y is you can plug your x into either the first equation or the second equation. And it doesn't matter which one you do, because like I said, whatever x and y combination is the solution, it's going to work for both equations. And you don't have to check both, but just pick one. And usually I like to go with whatever's easier. In this case, not one is easier than the other, so I'm gonna just pick the first one. And so what you do is you just replace x with whatever you solved it for. So I'm gonna rewrite it, and I'm gonna say 3 times, instead of saying 3x, I'm gonna say 3 times 3, because x is equal to 3. And then I'm gonna say minus 2y equals 17. Now, again, if you notice, you have one equation and one variable, so we can just solve for y. All right, and so usually when you have an answer, it is an x and a y, but remember, our answer is just an intersection point. So what we like to do is say our final answer is x comma y, and that is our solution. And a lot of the times they might ask you to check to make sure that's the right answer. And the way you do that is you just plug x in for 3 and then y in for -4. You can do one equation, or if you really want to make sure it's the right answer, you can do both equations. But if you did it right, it should work for both equations. So I recommend you pause the video and just plug in your x and your y into both equations and make sure it works out. All right, so in this next example, we got 5x minus 7y equals -28 and 2x minus 2y equals -12. Now, if you look, this is a good candidate for elimination, but you notice we don't have matching coefficients like in the last example. So these ones are a little bit trickier because like you low-key got to finesse the problem and force the coefficients to match up. And so what we can do is we can figure out, all right, between this 5 and this 2, is there some number that I can multiply both of them by such that they will have matching coefficients? And the way you do it is basically you want to find the least common multiple. And the way we can do that is I know that if I take the 5 and multiply it by 2, then I'll get a 10x. And then for the 2x, if I multiply it by 5, I'll also get a 10x. So we can both have 10x's. And the thing you got to be careful about is, remember, we want them to cancel out. So if we want the coefficients to be 10, one of them has to be positive and one of them has to be negative. That way they can actually cancel out. And so what I'm gonna do is I'm gonna take the first equation and multiply it by -2. So my first equation will get me a -10x. And then on this bottom equation, I'm gonna multiply everything by 5. And then this 2x will become a 10x. So I have -10x on top and then a positive 10x on the second equation, and then they'll cancel out. And one thing to watch for is when people do this, sometimes they'll mistakenly only multiply the left side of the equation. But when you multiply by a coefficient, you're multiplying the entire equation. So a lot of times I just like to put the parentheses on the whole equation to let me know to multiply everything by that coefficient. All right, so now that we got our matching coefficients, this looks like a good candidate for elimination. So just like last example, you're gonna add one equation to the other. And when I do that, -10x plus 10x, that's just gonna be 0x. And that's the elimination right there. 14 plus -10, or 14y minus 10y, that's gonna give me a positive 4y. And then 56 minus 60, that's just gonna give me a -4. So now, if I wanted to rewrite it, I can just say 4y equals -4, and then divide both sides by 4. So then I have y equals -1. And remember, that's not it. We still got to find our x. And so again, the way we do that is we just take our y value and substitute it into either equation. It doesn't matter which one, and then we find our x. All right, so I'm just copying the second equation. So I'm gonna say 2x minus 2. Now instead of saying y, I'm gonna say -1. And then that equals -12. And now again, one equation, one variable, I can solve for x. All right, and so our final answer will be x comma y. So it's gonna be -7 comma -1. And if you want, you can check it by plugging in the x and the y into both equations, and it should work out. All right, so the last method of solving systems of equations is called substitution. And problems are a good candidate for substitution when either the x or the y is isolated. Or in other words, it's like y equals something or x equals something. All right, so in this example, our first equation, this lets us know it's a good candidate for substitution because y is by itself. And this one, these take a little bit less work. So basically all you're doing is know that y is the same value as 2x plus 4. And so since they're equal to each other, you can interchange them. And the substitution part comes in when we use the second equation. Instead of writing y, we're going to replace it with something that's equal to, or in other words, 2x plus 4. So really all I do is rewrite my second equation, but instead of saying plus y, I say plus 2x plus 4 because they're the same thing. All right, so I literally just rewrote the second equation, but I said 2x plus 4 instead of y because they're the same thing. And if you notice, now I have one equation and one variable. And I know there's two variables, but it's one unique variable. And so I can solve for that. So just combine like terms, that's 5x plus 4 equals 9. And then a two-step. So that'll be 5x equals 9 minus 4, which is 5. X equals 1. And again, we're not done. We still got to solve for y. And the good thing about substitution is that now that we have our x, it tells us what y is. And y is equal to 2x plus 4. So all I got to do is replace x with what I just solved for, and then I'll have y. So I can just be like y equals 2. Now instead of saying x, I can say 1 plus 4. So y is going to equal 2 times 1 is 2, 2 plus 4 is 6. And that's it. So my final answer will be 1 comma 6. So in this next example, we're going to solve it using substitution. Now, if you notice, there isn't an x or y by itself, but you can easily force x to be by itself in my second equation. So all I got to do for this, if I add x on both sides, then these x's cancel out. So I can just bring down my -8y, and that's equal to 0 plus x, which is just x. So it was one little step, but now x is by itself, which means we can use substitution. All right, so since x is equal to -8y, I can just replace that in my first equation and then solve for y. All right, so all I did was rewrite my first equation, but instead of saying x, I replaced it with something that is equal to, which is -8y. And now I can just solve for y. All right, so I want y'all to look at this real quick. Before we solve for y, let's think about what we have. We have a -16y plus a 16y, which is really just 0y. And if it looks weird, it's because it does. Now 0 times y is just 0. So we have 0 equals 4, which obviously doesn't make sense, right? Those aren't equal. And so whenever you're solving systems of equations and you get something like this where the left does not equal the right, that means there is no possible x and y combination that makes this work. And so what this means is that there's literally no answer. There's no answer for this system of equations. And so what we say is no solution. There's literally, like, if you graph these, then there isn't a point at which both of these lines intersect. And if you think about what the graph would look like, if you can imagine two lines that are never going to touch, that means that those lines are parallel. So if you graph both of these, they should be parallel. and that means that they'll never touch. So that's why we say no solution. All right, so in this last example, you can pick which method you want to use. So a lot of times when y'all take tests or whatever, it'll be like solve the system of equation using whatever method. And this one, you can kind of go either way, substitution or elimination. Because on this first equation, if I add 2y to both sides, then I'll get x by itself. Or I can force the coefficients to be the same by multiplying the top equation by 3. So you can literally pick whatever way, and know that with all system of equation problems, you can solve any problem with any method. It's just that some problems are better suited for different methods. And so for this example, I'm gonna just go with, we'll do elimination. And so I'll multiply this whole equation by 3. And the reason I'm doing that is because if I do that, I'll know I have a 3x on the first equation and a negative 3x on the second equation. And so what I'm gonna do is I'm gonna rewrite the whole thing, but I'm gonna distribute this thing everywhere. So it'll really be 3x minus 3 times 2y, which is 6y, equals 3 times 3, which is 9. All right, and then my second equation, I can just rewrite that negative 3x plus 6y equals negative 9. All right, now, just like last time, I'm gonna add the second equation to the first equation. And like we wanted, we have a 3x plus a negative 3x, or 3x minus 3x, which is gonna cancel out, and that's just gonna give me 0x. Now look at here, I have a negative 6y plus a 6y. That's also gonna give me a 0y. And then I have equals 9 minus 9, which is 0. So this is kind of a special case where we have 0 equals 0. So this is a little bit different than the no solutions, because in the no solutions example, we had an equation that was not true. You know what I'm saying? We had like 0 equals 4, which is not right. Here we have something that is true, 0 equals 0. And so when you get something like this, that lets you know that it doesn't matter what x and y is. No matter what x and y is, it's always gonna come out to be something that's true. And so when that happens, what we say is we have infinitely many solutions. So there isn't just one intersection point. There's an infinite number of intersection points. And so if you think about it graphically, that means that if you have 2 lines and they intersect everywhere, the only way that can be is if those 2 lines are right smack on top of each other. So that kind of covers the 3 possibilities that we can have. We can have one solution, we can have no solutions, which means they're parallel, they're never going to touch. Or we can have infinitely many solutions, which basically means they're the same line. All right, so back to our basketball example from the beginning of the video. We got x plus y equals 37. Remember, the total number of baskets that we made was 37. And then we made 2-pointers and 3-pointers to total up to 80 points. And so I'm not gonna do this one for you. I wanna try to let you do this one on your own. But I wanna talk about what method we could use to solve this system of equations. So if I wanted to go the elimination route, I could make this coefficient be a negative 2, or I can make this coefficient be a negative 3. So you can choose if you want to cancel out the x's or cancel out the y's. Either way, you're going to get the same answer. Or what you could do is you can go the substitution route, and you can subtract y from both sides to get x by itself, or you can subtract x from both sides to get y by itself, and then do it that way. So the reason I did this example is to show you that there's not one way to solve the system of equations. You can do it any method, and you can use any variable. So it just depends on your personal preference. So try it out, see what you get. Let me know in the comments what you got, and we'll see if you get it right. So thank y'all for watching the video. Hopefully it helped. If it did, make sure you leave me a thumbs up. If you have any questions or any suggestions about what I should make in the future, make sure you drop a comment below. If you're new, don't forget to hit that subscribe button. And with that being said, I'm out.